Good day, everyone. Welcome to WiseLink Academy. Today, we want to look at a question under strength of material. As you can see at the right corner of the screen, the question says: a hollow cast iron cylinder 4 meter long, 300 millimeter outer diameter, and thickness of metal 50 millimeter, is subjected to a center load on the top when standing straight. The stress produced is 75,000 kilonewton per meter square. Assume Young modulus for cast iron has 1.5 times 10 raised to the 8 kilonewton per meter square, and find number 1, magnitude of the load, longitudinal strain produced, total decrease in length. So today we want to solve that question as you are seeing at the right corner of the screen again. So the first thing to do is to write out our parameters. So as you can see in the question, they said a hollow cast iron. Let me show you what that means. Let me use this pen for instance. Can you see this barrel cover? As you can see this, let's assume it's a metal. Understand? So let me show you how to explain. Let me show you how to explain very well. Let me show you how to explain. So this is what I'm trying to explain. You know, the question is saying a hollow cast iron. You understand? Cylinder. So in what we're having there, they mentioned outer diameter and what thickness. That is for a hollow cast iron. So let's say this is a cast iron. The meaning of hollow is that it will have hole in it. As you can see, it has hole in it, and it has what thickness. Or this side you are seeing here is what is the thickness. This side you are seeing here, thickness. I assume this is a rod, isn't it? It has a hole and has what thickness here. You understand what I'm trying to say now? So it simply means that this expression is known as what a cast iron cylinder, which has what a hollow. You get that now? So now let's proceed. Now if I proceed, writing out our parameter, isn't it? So our parameters, that is the givens that's given us in the question. A hollow cast iron cylinder 4 meter long. They gave us the length to be what? 4 meter, isn't it? So 300 millimeter outer diameter. Can you see that? You have the diameter, the outer diameter, it is DO, is what? It's 300 millimeter, isn't it? Let's proceed. And thickness of metal is 50 millimeter. So the thickness T is equals to 50 millimeter. That is this thickness I showed you earlier. This thickness here is what? Is that 50 we are seeing, and the outer diameter is the diameter for everything is what? 300. Do you get that now? So for me, I will explain that very soon. So it's subjected to a center load on the top when standing straight. The stress produced is what? The stress is what? 75,000 kilonewton per meter square, isn't it? Assume Young modulus. So our Young modulus is expressed as what? E to be what? To be 1.5, as you can see at the right corner of the screen, times 10 raised to the 8 kilonewton per meter square, isn't it? Now find looking for magnitude of the load. Our load can be L, or it can be P, or it can be what, F. I can express my load in these three terms. So looking for load, we're looking for what? Longitudinal stress produced. We're looking for stress. That is, our stress can be either of this stress, or you can put it as this stress. And lastly, we're looking for what? Total decrease in length. That is, we're looking for change. Can be like this, or you can express it like this. We're looking for that too. So we have written out our parameters and what we're looking for. Now let's start working. Solution. The first thing to do is to what? Draw out your own hollow cast iron. See, let me assume this is my hollow cast iron, isn't it? From here to here is my what? My D outer is given as what? 300 millimeter, isn't it? From here to here is my D inner. You don't know it, isn't it? But this from here to here is the thickness T. Thickness T, isn't it? So our thickness is given as 50, so that's 25. So for us to find our inner diameter, that will be what? Our inner diameter is equal to D outer minus 2T. So this is the formula I'm going to use to find our D inner diameter. So working on this, I'll be having D inner is equal to, our D outer is given, isn't it? D outer is what? 300. That will be 300 millimeter minus 2 open bracket, what? 50. Our T is 50. 50 millimeter. So D inner is equal to 300 millimeter minus 100 millimeter, because 2 times 50 is 100. So if I work on this mathematically, my DI is equal to 200 millimeter. So my DI is 200. That is my inner diameter is 200. It's 200 now. And my D outer is 300. So likewise my thickness is what? 50. Now the next thing to do is to start calculating for the area. The next thing is to look for the area. So area of a hollow cast iron is what? By open bracket D outer square minus D inner square over 4. So this is formula for if you want to find for the area based on hollow cast iron. Do you get that now? So if I insert my values, let's do that. But before inserting our values, I've gotten our D inner to be what? 200 millimeter. Now always remember that whatever your Young modulus takes as the final unit, that is what everything must have. So if I'll convert this one to meter, and I convert this to meter, doing that I'll be having this. So I'll be having 0.2 meter and 0.3 meter, isn't it? As my answer. If I convert millimeter to meter, I'll be having this, isn't it? So let's proceed. The next thing to do is to find the area. As I said earlier, this is the formula for the area. So now let's apply it. So let me show you. So A is equals to 3.142. You can see that it's pi, and pi is what? 3.142. So open bracket, the outer diameter is what? Is 0.3 square minus 0.2 square, isn't it? Over 4. If I work on this, my area will be what? 3.142 open bracket 0.3 square. I'll be having 0.09 minus 0.02, sorry, 0.2 square. I'll be having 0.04, about 4, isn't it? Working on this automatically, A is equals to 3.142 open bracket is 0.09 minus 0.04. I'll be having 0.05 over 4. So this can easily become, this times this, I'll be having 0.1571 divided by 4. So my area will now be 0.0392 meter square. So I've successfully found for my what? Area. The next thing to do now is to proceed by calculating for the one is force. Let's calculate for the what? Magnitude of the load. So calculating for magnitude of load, isn't it? So we know our formula that says that stress is equals to force over area, and I said our force, our load can be expressed as this F P L. So our load can be expressed as F as well. So if I multiply, I'll be having force, or let me call it my load, is equals to stress times area, isn't it? So if I proceed, my F will be equal to, stress is what? Is given as what? This value, 75,000 kilonewton per meter square, times area is what? 0.0392 meter square. So meter cancel, meter square and meter square. So my F will finally be 2.940 kilonewton. So our force is successfully this. Now let's calculate for the second other one. We are asked to calculate for the what? For the stress, that is longitudinal stress produced. And we know that our stress from the original formula, calculating for longitudinal strain produced, isn't it? So to calculate for this, our original formula means our stress is equals to change in L over L, or you say delta L over L. This is also delta, understand? Either of the two you apply them. But as we can see that in our parameter, we are not having change in L. We are only having what? L. And we are looking for strain. We can't look for two things at the same time. So that will lead us to the application of what? Young modulus. which is what is equals to stress over strain. So we can look for our strain using this formula, isn't it? So looking my strain is subject to the formula. I'll be having strain is equal to, I'll show you, strain is equals to, stress is what? Strain is equals to stress over Young modulus, isn't it? If I work on this, my stress is what? I'm having, let me show you, my stress is 75. My stress is 75,000 kilonewton per meter. So we're having 75,000 kilonewton per meter divided by our Young modulus is given as what? Let me show you. So our Young modulus is what? 1.5 times 10 to the power 8 kilonewton per meter square, isn't it? So it's given like this, isn't it? So I can easily cancel out this and cancel out this. So my strain is equals to 75,000 over, if I work on this indices in this way, that's 15 over 10. This expression is 15 over 10 times 10 to the power 1, 2, 3, 5, 6, 7, 8. 10 to the power 8 simply means this. 15 over 10 simply means this. So if I cancel out this, I'll be left with 75000 divided by this should be my answer. You can press your calculator directly to give your answer, but with that calculator you can survive using this method. So you cancel out this, you time this to this, you're having this. So I can just cancel out the zeros, cancel out this. So I'm left with my strain is equals to 75 over 15,000, isn't it? So 150,000, yes, 150,000. I'm left with that. So if I work on this, my stress will give me 75 here by that value. I'll be having 0.0005. Stress does not have units. That is why it has what? The unit has cancelled out each other here. So it does not have unit. Take note of that. So my calculation for longitudinal strain produced is what? 0.05. And lastly, I want to calculate for our that is our total decrease in length, or we call it delta L, the change in length. So let's proceed. Calculating for decrease in length. So you know that our decrease in length is from this formula, that is strain is equal to change in L over L. So these are decrease in length. I can now make this one to be the source of the formula. Now we what? Change in L is equal to strain times our length. And we have successfully got the value of our strain to be 0.005. Let me show you this value. 0.005 is our strain, so you apply it there. So but strain is equal to 0.0005 and our length is what? It's going to be 4 meters. According to our parameter, let me show you. Our length is 4, isn't it? So proceeding, if I work on this, I'll be having change in L, or delta L, is equal to stress 0.0005 times 4 meters. If I times it together, I'll be having is 0.002 meter. So my change in L is this. So finally, my answer is going to be this. My force, or I call it my force, or I call it this, is equals to, my force is equals to 2.940 kilonewton. If I move on, my strain, or I call it to be this, is equals to 0.0005. So, and lastly, my change in L, that is decrease in length, is equal to 0.002 meter. So if you found this video helpful, kindly click on the subscription button and like. Welcome to WiseLink Academy.